Okay. So let's take a look at this and see if we can figure out this value. Today we're actually going to learn where this piece comes from that we have seen so many times, because this is an actual thing. That's what we're going to start with today. So, what do we do to evaluate this expression, b squared minus 4ac, if a equals 6, b equals negative 3, and c equals 1? What do we do? Yep. Ooh, hang on, I gotta make that pen actual thickness, because that is like 1 pixel thick. So we're gonna substitute in our negative 3 in place of that letter b. Still get squared? Mm-hmm. And substitute c with 1. And then we can simplify that, because we know that negative 3 squared is going to give us 9. And we know that 4 times 6 is going to give us 24. Now it's beginning to know the screen is really annoying. So what do we get as our final answer on this? Negative 15. So we have seen this expression several times before, that b squared minus 4ac. It has come up in bell work, it's come up on homework assignments, it's come up on stuff. The reason we've had to use this pattern so frequently is it is a very important part of a very important formula called the quadratic formula, which is one of those like Pythagorean theorem was a really big thing. This is a really big thing. It's one of those big equations that we used to have to memorize by rote a lot. I remember when I first learned it, we literally marched around my elementary school chanting it, because it was in like 8th grade, because I was honors. So like we chanted it around my elementary school. It was kind of like a creepy little math cult. So we used to have to work on memorizing the formula itself. It is long and it is complicated looking, but it's not bad to use. So we're going to look at it. We're going to see what it's about. We're going to work with this formula over the next couple of days. And what it is a way we can solve quadratic equations every single time. We don't run into any cannot factor, any of that stuff. It will get us an answer every time. It's just not always the simplest way to get to an answer. So this is the quadratic formula. And in fact, I should have one more thing. It should say x equals. This is the quadratic formula right here. If I fill in my a, b, and c, it will tell me what my x is, what my answers are. This is, you will have this, we will write this on the next page. You don't have to write the whole formula down. We're not using the whole thing today. Right in here, under this square root, that's the guy that was in the bell work that we've seen before. This bit under the radical right here is what we're going to work with today. We're just going to work with this little bitty piece. That specific piece, this under the square root part, has its own little name. So just this guy, we're not including the square root, just the guy underneath. It's called the discriminant. Because it helps us figure out what kinds of roots we're going to have when we get all the way down to the answer. Because we've had times when we have 2 real roots. I can point you, but it's where it crosses the x-axis. We've had times when we've had 1 real root, where it comes down and bounces right back off my x-axis. We've also had times when we haven't had any real roots. But if we don't have real roots, what we do have are imaginary roots. So we're going to be using this to help us figure out if we have 1 real root, 2 real roots, or 2 imaginary roots. So the discriminant tells us how many real roots, or solutions, or zeros, or x-intercepts. Those are the synonyms again. Solutions. X-intercepts. or zeros. You don't have to put all 4, but they all mean the same thing, and they gave us a big enough line anyway. So, might as well. They all mean the same thing. It tells us how many real roots, how many solutions, how many zeros, how many x-intercepts. So what we're going to do is we use, from our equation that we have, our A, B, and C. That's where we get our A, B, and C from, is from our equation. So here's a few examples of what it looks like when we have our 1 real root or our 2 real roots or our no real roots. And what we're going to see is when we have our discriminants, that b squared minus 4ac, when we get a value that is bigger than 0, so when we get a positive number, so if my discriminant winds up as a positive number, we get 2 real roots. That's what it means when it says this greater than 0. It means we get a positive number. We have 2 places where this is crossing my x-axis. I have 2 solutions. So if what we get for this is positive, we have 2 real roots. We will have actual numbers. If when we substitute in our A, B, and C, we get exactly 0. 0, just 0 and nothing else. If we get exactly 0, that's when we're going to have 1 real root. So if our discriminant is exactly equal to 0, we have 1 real root. Because this is going to come down and it's going to bounce back off. One of the big benefits of the quadratic formula is actually in this first one here. Because if our discriminant is less than 0, meaning this is a negative number. So less than 0 makes it negative. That's when we used to say, we would say it had no real roots. But if it does not have real roots, it's going to have imaginary roots. So this will have 2 imaginary. So now that we know how to deal with I, and we've worked with those in square roots before, we've dealt with all those things, now we're actually going to be able to get to an actual answer, a solution, an x equals, even when we have imaginary roots. They're not real. So what we're going to start with today is we're going to be looking at some equations. We're going to find our A, B, and C, and we're going to find out how many roots there are. So if we get a positive number, we're going to have 2 real roots. If we get a negative number, we get 2 imaginary roots. And if we get exactly 0, we have 1 real root. Okay? So this is that table at the very bottom of the page. It kind of splits across the page, so I've tried to set this up so it's exactly the same. So we have here our quadratic equation, x squared plus 3x minus 4 equals 0. Really, really important. Whenever we're looking at these and we're taking our A, B, and C, has to equal 0 every single time. So before I start finding A, B, and C, I have to make sure this is set equal to 0. It's very, 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 very important, not optional. So since this one is set equal to us, love that, or to 0 for us, we can find our A, B, and C. What is the A value for this equation over here? 1. It's the number in front of our x squared. A is always the number in front of our x squared. So our A is a 1. What's our B? 3. B is with the just x. So our B is 3. What's our C? Negative 4. We got to make sure we're paying attention to those signs. So our A is 1, our B is 3, and our C is -4. That middle box that says value of the discriminant, we're going to substitute those values in just like we did in the bell work. Our B squared minus 4AC. You might want to write it down because it's not written at the top of the table. You might put that piece down there because we're going to use that same formula for every single time to find the value of our discriminant. So what we're going to do is we're going to substitute those pieces in just like we did in the bell work. I'm going to put my B3 in place of the letter B. So we're going to have our B squared minus 4 times our A, which is 1, times our C, which is -4. That is a very, very common mistake, is to flip around which letter goes where. It is really important that they go in the right spots. I almost always am going to color code, and I am almost always, I pretty much always put B as blue just because it works for my brain. So make sure when you're substituting pieces in, you get things in the spot where they're correctly labeled. And then we're going to simplify this as much as we can. Now you can type that whole statement into the calculator. I could put 3 squared minus 4 times 1 times -4. Make sure you include the parentheses if you do. We also can do this by hand. It's not that hard. Because we know what 3 squared is. 3 squared is 9. 4 times 1 is 4. Yeah, -4 times -4. Positive 16. So we're going to have plus 16 because those two negative signs cancel each other out. Well, 9 plus 16 is 25. So the value of the discriminant is 25. Questions on that part? Now here's the big question of the day. Is this positive, negative, or 0? Positive. This is a positive number. Since we have a positive number, that means my discriminant is bigger than 0. It is positive. So we're going to have 2 real roots. So since this is positive, since it's greater than 0, we are going to have 2 real roots. You don't have to put the greater than 0 thing, but that's just how we know that. Because this is a positive number, this is bigger than 0, we know we're going to get 2 real roots.
That's all we're doing today?
I mean, we're going to do it several more times. I would say, if you turn a page, there's several more copies at the table. We're going to try it several more times. We're going to get all the way to the bottom, page 16. They don't take super long. They don't take super long. We're good. We still got 20 more minutes, man. It's all based on this discriminant stuff. So we find our A, B, and C, we substitute them in, and then we can check against that table. So let's try it again. So here's top of page 16. What is our A value? What's our A? -4. It's the number in front of our x squared. Yep. Our B is going to be 2. And then our C is 1. So we're finding those from our equation over here. So when in doubt, kind of match it back up here. So A is always in front of the x squared, B is always in front of the x, and C is my number that doesn't have anybody's with it. So when we substitute those into our discriminant, we're going to have our 2 squared minus 4 times negative 4 times 1. What do we get as the value of our discriminant? Say it again. 20. Our 2 squared is going to give us 4. Minus 4 times minus 4 gives us a positive 16. 4 plus 16 gives us 20. So now that we know that the value of our discriminant is 20, what kind of roots are we going to have? Two real roots. That is a positive number. If we have a positive number, that means we have 2 real roots, 2 real solutions. Positive numbers mean we have 2 real roots. Questions on this one? So very, very similar. We're going to keep working down this table, finding our A, B, and C, identifying these pieces. What's our A on this one? -1. Be really, really careful. Signs are super duper 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 important on these. What's our B? -4. And what's our C? -4. So we have a lot of negatives in this one. Make sure you put in parentheses if you're doing it in the calculator, or you are paying very, very careful attention doing it by hand. Either way, we're going to need to be careful, because we need to make sure we're doing -4 squared, -4 times -4, minus 4 times our -1 times that -4. And again, this is something you can put in the calculator, like absolutely valid to do so. I forget how many negatives there are if I don't look at it. Like I could put in my parentheses -4 squared, just like this, minus 4 times -1 times -4. You can put it in just like that. It is very, very important that we use negative signs inside the parentheses, and that's different than the minus sign that's outside. You can even kind of see it on the screen, how these ones are really little and up a pixel. So the calculator sees them as different, but it's going to spit out our answer for us. So you can use the calculators for this. It's absolutely valid. Type it in. We've got the tools. So the value of our discriminant here is going to be 0. So if the value of our discriminant is 0, how many roots are we going to have? If our discriminant equals 0, how many roots do we have? 1. That's this one in the middle. When our discriminant equals 0, of course now my iPad decides to freeze. When our discriminant equals 0, then we're going to get 1 real root. It's going to come down here and it's going to bounce right off. So we would have 1 real root, or 1 real solution. So if the discriminant equals 0, it means 1 real root. Questions on this one? Got 2 more in this table here. what is our A value? One. What is our B value? 4. Good. And what is our C? 6. Beautiful. Substitute them in. We have our 4 squared minus 4 times 1 times 6. Substituting in our pieces. Simplifying as much as we can. What do we get as the value of our discriminant? What do we get when we simplify 4 squared minus 4 times 1 times 6? Negative 8. And you can do that in pieces. 4 squared, we know that's 16. 4 times 6, that's 24. So this is the same thing as if I had 16 minus 24. And that's going to give us a negative 8. So the value of our discriminant is negative 8. Which means what kind of solutions are we going to have? 2 imaginary roots. If we get a negative number, we are going to have 2 imaginary roots. So a lot of times when we're working with that big formula, that big kind of ugly thing that we started looking at, we're going to start by doing this. So we will know going in that we expect to find imaginary numbers, so it shouldn't be a surprise to us. So this is going to be our first step, simplifying the discriminant whenever we're working with that quadratic formula. So we will know going into it that we're going to expect to get imaginary answers, so we're not going to get surprised by them. One more like this, and then we'll do that bottom half of the page, which is kind of a matchy situation. One more like this. So very similar vibes. What's our A? One. That's the number in front of my x squared. If there's nothing written there, it's a 1. What's my B? 2. And what's my C? 1. So we find our coefficients. We're going to substitute them in. And we're going to simplify. So our B, wrong color. B squared minus 4 times A times C. What do we get when we simplify? What is 2 squared? 4. And then 4 times 1 times 1, that's just 4. So we have 4 minus 4. 0. So the value of our discriminant is 0. Which means how many roots are we going to have? I heard it. It was very soft and tentative, but it was there. We're going to have one solution. If our discriminant equals 0, that's when we're going to have our one real root. One real solution, one real x-intercept, one real 0. Scan stuff. Okay, so questions on the calculating of the discriminant and how we find it? Because the bottom half of this page gives us 3 different discriminants and 3 different graphs, and we're going to match them, is what we're trying to do. So we have these 3 pictures. And we have these three discriminants that they've given us. They're just telling us the value. They're not telling us A, B, and C. They're saying, all right, we already did that, and we were giving you a number. So what we're going to do is we're going to look at our discriminants, and we're going to look at our pictures and see what things we can match up. So if we look at equation A, we see that we have a discriminant with a value of 3. It equals 3. Is that positive, negative, or 0? That's a positive number. So we know that this guy has a positive discriminant. How many roots do we expect this to have then? This should give us 2 real roots. Can we see a graph here that has 2 real roots? Which one of these pictures? Yeah. Graph number 2 has 2 real roots. One here, one here. So discriminant A goes with graph 2, which there's a sentence at the bottom that says graph 2, discriminant is blank, A. And how many solutions does it have? 2 real solutions. So this kind of like takes up a lot of space, but it's just matching. So then if we look at equation B up here, we're told that their b squared minus 4ac, their discriminant equals 0. So is that positive, negative, or 0? Zero. Which means how many solutions will this have if we have a discriminant of 0? What does 0 mean? 1. Here we're going to have 1 real root, or 1 real solution. Do we see a graph here that has 1 real solution? Does 1 have 1 real solution? Where would our root be? Remember, root, solution, zeros, x-intercepts. Which graph has 1 x-intercept? This guy doesn't touch the x-axis at all. It's a little bit low. This guy only touches 1 time. So for 1 real root, that's our 1 real root. It's hitting my x-intercept right there. So graph 3 is going to go with discriminant C. Discriminant B, excuse me. I'm good at reading. So these guys will go together because both of them have 1 real root. And we've been process of elimination it, but we're still going to think it anyway. So, mwahaha. So then doing the same thing, I can look at C up here. And I can say, all right, my discriminant, positive, negative, or 0. Is that one positive, negative, or 0? For C. Negative. If we have a negative discriminant, that tells us we're going to have what kind of roots? We're going to have no real roots. You could also think of that as 2 imaginaries. So that means we don't have any real numbers that cross that x-axis. I don't touch it. We have pretend touching. We have pretend roots. They are imaginary. They were made up. So, again, process of elimination, we can see it. We can also look over here and say, hey, this guy doesn't have any places where it crosses the x-intercept. I don't have any root solutions or zeros. So I know that this graph has to have a negative discriminant. It has to have a negative discriminant. So you can do it from the graphs to our discriminants, or we can go from the discriminants to the graphs. You can go either direction. But either way, graph 1 is going to have discriminant C. I'm just going to bring it up and over there. And they have 2 imaginary roots. Okay? Questions on these ones? Because we're going to use these tomorrow. We're going to use this discriminant. It is a key component and a absolutely vital part of the quadratic formula. We're going to use the full quadratic formula tomorrow. I promise it looks scarier than it is. And we're going to use that to help us find some solutions for quadratics. That does not require us to do completing the square, because huzzah, I know that one's gross. So what I'm going to give you is the next homework. There we go. It is going to be due on Monday. And the homework is set up a little bit backwards because this is what we're doing tomorrow on the front. And what we did today is the top and the bottom. This will be a tomorrow thing. But the top and the bottom on the back, you can absolutely do. This and the middle one on the back are what we are going to do tomorrow. So I'm going to pass mail. This is the second to last homework of the chapter. So make sure you get your homework turned in. You got about 8 minutes until announcements start. So if you have questions on 3-5, now is a great time to ask them. Finish it up, get it turned in, and all that jazz.